Hello students, I welcome you all to my channel Education Link. Before teaching you mechanics of a multi-particle system, I am going to tell you about center of mass and its equation and a few lines or a definition about degree of freedom and constraints. So let's get started with the center of mass for a system of particles. Let us consider that my system consists of n number of particles. Capital N number of particles. This is my system in Cartesian coordinates x, y and z. This is my origin O. Now there will be lot of particles. There will be n particles. So let us consider the ith particle. The position vector of ith particle would be Ri. I am denoting my position vector of ith particle with Ri vector. Similarly, you can denote other particles like R, J, M, N, and please remember this I, J, K, L, M, these all are dummy indices. Means dummy indices, what are dummy indices? It means the indices which I can change according to my convenience. Okay, you are considering this system with n particles. You can name this particle as I or this particle as I, this particle as I. It is up to you. So these are dummy indices. I can indicate this Ri with the Rj also. So it is up to you. So these are dummy indices. So let the mass of each particle of the system is Mi. The mass of these particles I am considering is same, Mi. So I can also write summation I is equal to 1 to n over Mi is equal to capital M, the total mass of the system. Now, what does the summation means? It means I am summing up all the masses of the particles varying from particle number 1 to total particles n. Suppose there are 10 particles, then it will be go from I is equal to 1, I is equal to 10, and that will denote my total mass of this system. Correct? Now my main topic is center of mass. Now this whole sub-object, these all the particles are making an object, are making a body. So the total mass, I got it like mass of the system is capital M. Okay. I have considered small ri, the position vector of this ith particle. First, I will tell you the definition of center of mass before proceeding further for the equation of center of mass. Center of mass is the point of the system or the body, or you can say object, on which after applying some external force, it will move as a whole. What I meant by saying this statement? There is a small example. Consider there is a wood log. Wood log means एक लकड़ी का बड़ा सा टुकड़ा पड़ा है. So how will we find the center of mass? Or you can consider a pencil. which you can easily perform, or you can try to do it your own. Now, if you try to handle this pencil from here, it will fall down. If you try to hold this pencil from this point, it will fall down. If you hold it from here, it will fall down this side. If you hold it from this point, it will fall down this side. But if you hold it or stand it from somewhere around the center position, it will not fall down either in this direction or either in this direction. So this point is known as center of mass of any object. Similarly, for other objects, you can find the center of mass of an object. So here I am considering the equation of motion for center of mass of a system of particles. So this is my center of mass. This is say my center of mass of this particle I am calculating. Let the position vector of this is capital R. So now I have to find out what is capital R and what will be the equation of motion. So let's proceed further. The total force applied on the system. The total force, this is external force applied on the system. Now let me tell you, consider these two particles. I am writing it here. These two particles, there is some space between them. This particle 1, 2. This particle will exert force on this according to Newton's third law of motion. And second particle will exert force on the first particle according to Newton's third law of motion. Every action has equal and opposite reaction. Because it is equal and opposite, so consider this is applying F force on 2 and this is applying also F but in negative direction, but it is opposite. If I sum up both, it is negative F, this is 0. So basically the forces which these two particles are applying on each other will neglect each other. Similarly, other particles also will neglect the internal forces. So the total linear momentum of the system is equal to the derivative of the linear momentum is equal to the total force. This total force is external flow force plus internal force. But this internal force, I told you, it cancels out to be 0. So I am considering this Pi dot summation I is equal to 1 to n F, I am writing it E now, F external, or simply I am writing it F. It is understood that it is external force. Now what is momentum? Ri dot, what is Ri dot? Ri dot is V and momentum is mv. Got it? Now I have to derivate this because it is derivative of this. So d by dt summation over I is equal to 1 to n. This is my total external force acting on the object. Got it? Now multiply and divide by total mass or the sum of the masses of all the particles. Total mass is m. This is d by dt. If I write it simply as r vector, r position vector, then I can write it like double derivative, and this is simply Ri. I is equal to 1 to n divided by I is equal to 1 to n. This is also m. So I multiply and divide it by same term. So no effect will be seen. This is total external force. I am taking this my capital M out of the system, out of the equation, not of the system. This is my summation over I M R I. Fine. Now my this equation seems like that of F is equal to ma. This is F, this is m, this is acceleration, or the double derivative of some position vector. Let denote this term by r. So what is this? This is position vector. And now what is this position vector for? This position vector is the position vector of the center of mass of that body or object. This is my equation where r is position vector of center of mass. What is r? Summation mi ri upon summation mi. Obviously summation is over. This is my position vector. Done. Now let's continue with this position vector. This is what? Total mass of the system upon m r is equal to. Now what it seems like? It seems that mr, the product of mass of center of mass, of the total mass of the body into the position vector center of mass is equal to the masses of individual particles into their position vector. So let us proceed further, and with this I'll do the momentum for center of mass and what will be its velocity. Got it? Now from this equation, how will I get the momentum for center of mass of that object? Differentiate this. This is differentiation. Mi Ra dot over I. Summation is over I, understood. I am not writing it again and again. Now what is this? Momentum. I can write it like, what is this? This is velocity of center of mass. Okay. This is equal to mi vi. And what is this? Velocity of ith particle of the system. So it is simply, so my total linear momentum of the center of mass is simply equal to the sum of all the linear momenta of each individual particle. Got it? Now differentiating it again, what I will get? This is not derivative, this is simply V. From here, mr dot, I get V. I'm so sorry, this is not V dot. Differentiating it again, then I got V dot is equal to mi vi dot. Now what is this? Acceleration. Again, acceleration ma, force, is equal to the sum of all the individual forces. Got it? Now, what if the total external force applied on the system is 0? Then my this term will be equal to or equated to 0. M V dot is equal to F, total external force, and if it is 0, then M V dot is equal to 0. The mass of body, the mass of object cannot be 0 in any situation. So M is not equal to 0, V dot is equal to 0, and when this will be equal to 0, then I can write it like this: dV by dt equal to 0. This will be 0 and this is constant. So, if my total external applied force is 0, then velocity of center of mass will always be constant throughout. So, this is the result. Now, using this center of mass equation or center of mass concept, I am going to tell you about a multi-particle system or a system of particles, which I will teach you in the next video. Today I am going to tell you two small definitions or two small concepts: degrees of freedom and constraints. So let's get started with the constraints and degree of freedom. Constraints and degree of freedom. Degree of freedom. Freedom से पता चल रहा है कि there will be some freedom for the particle. Now consider a particle or a fly in your house, fly in all directions, in all the possible directions. What are the possible directions according to Cartesian coordinates x, y and z? So a fly can fly. Fly means makhi. It can fly in all the directions x, y, z. So its degree of freedom, the freedom in which it is its freedom in which it can roam about. So its degree of freedom will be 3. X, y and z, because it can go in 3 directions. Okay. It is denoted by small f. Degrees of freedom. For a fly, degree of freedom is 3 because it can rotate, because it can roam in x, y or z direction. Now consider another example. Consider a pendulum. Pendulum is rotating like this. It is going in only 2 directions, in this and this. And this plane is what? This is x, y and z. The pendulum will go first in this and then in this. So it is basically in 2 dimensions. It is not rotating like this. It is going from to and fro. So the degrees of freedom will be 2. Okay. Now what are constraints? Constraints are those quantities in which my object cannot go. Here in this case, in the pendulum case, my pendulum is rotating like this. It is not going into the 3rd dimension. So this 3rd dimension is the number of constraints because it is not able to go in that direction. So for pendulum, number of constraints will be 1. Consider another example. This is a sphere. An object is on the top of this sphere. Now this object can move only on this surface. It cannot go inside the object, and for some condition it cannot go outside. It can only attach to it. So what will be its movement like? It's a sphere, so equation of sphere will be x square plus y square plus z square is equal to a square. A is the radius of the sphere. In polar coordinates, this is the center O. Its radius is same, correct? But what is changing? The theta angle. The theta is the position of that object on the sphere. So theta is the only freedom or degree of freedom for this particle. So constraint for this is that it cannot go inside, it cannot go outside, and freedom is like it can rotate only on the surface. So this is my constrained motion of that small object. Constrained motion means the radius is always a, and for this object also its position is always at a. So this is my constrained motion. A fly is flying, it is 3. You can also think of other examples. So my main concept is to tell, so how do we find the total degrees of freedom for any object? Let us consider there are n particles. If one particle can move in 3 directions, or we can say it has 3 dimensions of motion, one particle has 3 degrees of freedom, n particle will be having 3n degrees of freedom. Now there will also be some constraints also. If there are some constraints, then it is denoted by small k and it is subtracted from the total degree of freedom. This is my effective or resultant degrees of freedom. Correct? You can think of many examples. So this is all about constraints and degrees of freedom and center of mass and its equation. In my next video, I am going to teach you about multi-particle system and its conservation laws. Till then, if you have any doubts, you can ask me any question in the comment box. I will surely answer them. Please subscribe my channel Education Lane for further videos. Thank you so much. This is for today.